Welcome back. So in this video, we're going to dive deep into queues and we're going to explore the different types of queues, which include we have simple queues, we also have circular queues, and we have priority queues. So by the end of the session, we're going to understand what these queues are, and in the next video, we're going to look at an example of how you can implement a queue data structure. So to start us off, we are going to start with a simple queue. And to simply understand a simple queue is it is known as a linear or a basic queue, and it follows the FIFO principle. Now we've looked at the FIFO principle before. It stands for first in, first out. So it's like a line at a store where whoever gets in the line first is the one who is served first. And in this type of a queue, there are two things that you can do. You can enqueue and you can also dequeue. Basically, when you talk of enqueue, we mean adding an element, and we can only add an element to the rear of the queue, hence what we refer here as insertion. And you can also do a dequeue where you can remove an element that happens at the front of the queue, and that is what we're referring here as deletion. So these two operations are really important when you're talking about simple queues. And simple queues are great examples or scenarios where they're used, such as in task scheduling, where the first task to be added is the first one to be added, or rather is the first one that is going to be executed. Now to just simply see how you can represent this in a code, just a simple example of how you can represent a simple queue using a Python list. So you're going to have a queue here, and you'll have a Python list. And so for you to add an element to the queue, all you need to do is just say queue dot append, and you specify an element that you want to add. So this is what we refer to as enqueue. So here we are basically going to, and this is enqueue. We're adding an element to the front of the, or rather at the rear of the queue, right? And then we can also add another element. Let's say we add another element, so just queue.append, and you can add another element like that. Then now, if you want to remove an element from the front of the queue, you can just simply use the pop method. So just say queue.pop, and you just specify. So let's say you want to, let's say, pop an element at index 0, which then if you go ahead and run our code, in this case it's python 3 queues.py. Okay, we need to print the queue again. So we're going to print the queue here, and I want us to print it in two scenarios. So we have before the pop and after the pop. So I'm also going to print the version of the queue before, like that. Now, if we run our code, as you can see here, we added two elements, so that is 1 and 2. And here, even if you remove this 0, and we run this code again, you see it still removes an element, right? So just when you say .pop, it's going to remove the element that is at the front of the queue. And this is a simple implementation of a simple queue data structure. So here, this is the dequeue. This is the dequeue operation that we've done right now. Now, moving on, the next data structure or the next type of a queue is what we refer to as a circular queue. Talking of circular queues, the key difference between a circular queue and a simple queue is that, unlike the simple queue, the end of the queue in a circular queue wraps around to the front. So basically, there's a connection between the front of the queue and the rear of the queue. So this is a more memory efficient because it prevents wasted space. So think of it as a never-ending circular track, basically. And in circular queues, which are often used in fixed size buffers, like when you're managing limited memory. So in an example of CPU scheduling, or you're buffering streams of data. Now, operations like the dequeue operation and the enqueue operations that we are able to do with our simple queues behave the same way in a simple queue, but the only thing that we need to do is we need to manage the wraparound logic that applies when you're talking of a simple queue, or rather when you're talking of a circular queue, that is. Right. Now, the next step of a queue is a priority queue. And to just understand priority queues, basically, they don't follow the FIFO rule strictly. Now, do remember that the simple queue and the circular queue, all of them, they follow the FIFO, the FIFO principle, that is. And for them following the FIFO principle, that means that strictly the element that is at the front is the one that is going to be removed first, and the one that is at the rear is going to be removed last, right? But here it is removing or adding an element, or basically a task being completed, is dependent on the priority that is attached to that task. So the task that has the highest priority is going to be dequeued first, regardless of the position. It could be the basically the latest task that was added, but it has a higher priority than all the other tasks that existed before. Hence, it's going to be executed first. So priority queues are used in scenarios such as job scheduling in operating systems. This is in scenarios whereby certain tasks are more important, and those tasks must be processed first. Those are some of the scenarios where we find ourselves using the priority queues. So now what we're going to do is we're going to see how we can represent a priority queue in Python and using the Python's heap queue library. And so to see how you can represent priority queue, oh, by the way, this is also an example of how a circular queue looks like. So basically, it's a never-ending circle, like we saw earlier. So talking of priority queues now, how we're going to represent this? We'll just remove all that and start afresh here. So to implement, we're going to further use we're going to use the heapq library, and the first thing we're going to do is we're going to import the heapq library. So we're going to import heapq, and this is going to provide us with functions that are going to help us implement a priority queue in Python. So the heap queue allows us to manage elements in a way that ensures the smallest or highest priority element is always at the front of the queue, right? The next step for us from here is we're going to initialize a priority queue. So we can just have a variable and we're going to call it priority underscore queue. So we initialize a priority queue like that. So this is going to basically act as our priority queue. And although we're representing it as just a list, the heap queue functions will still treat it as a priority queue behind the scenes or the backend, basically. So using a list makes it easier for us to manage or rather sort of manage the elements that are going to add to our queue. The next step for us from here is going to be adding elements using the heap queue. Heap queue has a heap.push function to it that we can use to add our elements. So the heap.push function, rather, we use it to insert elements into the priority queue, and each element is a tuple where the first value is the priority and the second is the actual data. So how you do that is using heap queue, which we already imported. So it has this, the heap queue has the heap push. So we can use this heap push. It has the heap push function that we use, and this heap push takes in two arguments. The first argument is going to take in is basically the first value, rather, is the priority that is attached to that element. So let's say we give it a priority of 1, and the second is going to be the actual data. So if the actual data, we say here, just some text to help us understand what you're doing. So this is going to be, let's say, the one and the element that has the lowest priority. So okay, I need to basically first of all specify that we are adding to the priority queue. So we need another. So here a heap.push. Remember, we are pushing to the priority queue. So here we add priority queue. That's why we were seeing that error earlier. So but now everything is okay. So here we are pushing this element to the queue, and we can go ahead and add another one. So you can also go and just say heap. heap queue dot heap push, and we are pushing to the priority queue. Then this second element is going to be we're going to just call it high priority. We're going to give it a high priority, that is like that. So now after doing this, the lower the priority value is going to be, the higher the actual value. But again, it could be vice versa. Sometimes you can, if something has a higher priority, it can also have a higher, basically a higher value. Depends on how you're going to represent it, basically. But in this case of ours here, this first one here is the one that that has a value of 1. We basically are going to we're going to sort of assume that this is the one that has a lower priority, and this one has a higher priority since it has a lower value. Yeah. So when these elements are pushed to the queue, the heap will basically, it will automatically reorder them such that the element with the lowest priority value is the one that is going to come, the one that is going to come first. Yeah. Then the next thing that we can do from here is try to remove the element that has the highest priority. So how we do that, we can just print out to see what you're doing. We're just going to say heap queue dot heap pop. So heap pop is the function we're using here, and then we specify we're doing this operation on the priority queue. So when we use this pop, it's going to remove and then it's going to return the highest priority. Again, do remember that the element with the lowest priority value comes out first, right? So low priority value, that means it has a high priority. Yeah. And in this case, this is the element that we expect for it to come first. So if we run our code here, you see that is the element that we're getting. It is the one that is coming out first because it has the highest priority. So it gets worked on. It gets worked on first. Now, the beauty of priority queues is that they don't rely on the order in which elements are inserted. Unlike the other queues that you've seen, that is the simple queue and the circular queue, this one does not rely on the order in which the elements are. It's only going to basically follow the priority. If an element has the highest priority, it's going to be basically worked on first, right? So an example that you can think of here as well is, let's say if you are let's say even at the job place where someone is working and they're getting in tickets, there are certain tickets that are going to be worked on first and others is going to be later. So for example, if someone is working at a internet service provider company, and then they receive a ticket that there's let's say their their internet cables have an issue somewhere and people are not receiving internet, that is going to receive a higher priority as opposed to someone complaining about the internet speeds, right? So that for internet speed is going to be probably a second priority to it. That's a sort of a real life example on that. But basically, what we've looked at so far when it comes to the types of queues, we've seen how we've seen the simple queue, how it works, the circular queue, and this is also a representation of a circular queue that you can see here, and also priority queue. So now in the next video, we're going to look at a practical application of the queue data structure and how it is used in generating binary numbers. Thank you, and I'll see you then.